Multitasking and cognitive load. Multitasking refers to performing two or more tasks simultaneously or switching rapidly between tasks. In modern life, multitasking has become increasingly common as people juggle work, social interactions, technology use, and personal responsibilities. Smartphones, computers, and other digital devices constantly demand attention through notifications, messages, and multiple applications. While multitasking can appear efficient, research in psychology and cognitive science shows it significantly affects mental performance, learning, and overall well-being. To understand the effects of multitasking, it is important to examine cognitive load, which refers to the mental effort required to process information and complete tasks effectively. Cognitive load represents the amount of mental energy the brain uses to acquire, process, and retain information. Human attention and working memory are limited resources, and when cognitive demands exceed these limits, performance declines, errors increase, and fatigue or stress may result. John Sweller's cognitive load theory identifies three types: intrinsic, extraneous, and germane. Intrinsic cognitive load is the complexity inherent in a task, determined by how much effort is needed to understand or perform it. Extraneous cognitive load comes from how information is presented, such as poorly organized instructions or distractions. Germane cognitive load refers to the effort devoted to learning and integrating information. Managing cognitive load effectively is essential to maintaining focus, learning efficiently, and performing tasks successfully. Multitasking increases cognitive load because the brain must divide attention or rapidly switch between activities. Dividing attention reduces the brain's ability to process information accurately and efficiently. For example, writing an email while participating in a detailed conversation may result in mistakes, misinterpretation, or slower comprehension. Working memory, which temporarily holds and manipulates information, has limited capacity. Splitting attention between tasks overloads working memory, reducing efficiency and increasing the likelihood of errors. Task switching, a common form of multitasking, incurs what is known as the switch cost. Each switch requires the brain to disengage from one task, refocus on another, and then reorient back, which slows performance and increases cognitive strain. Technology intensifies multitasking and continuous partial attention. Digital devices provide constant streams of information, prompting individuals to switch between work, social media, emails, and notifications. This constant division of attention reduces comprehension, impairs memory, and diminishes problem-solving ability. Frequent multitaskers may struggle to filter distractions, sustain attention, and maintain high-level cognitive performance. Over time, excessive multitasking contributes to mental fatigue, stress, and decreased overall well-being. Multitasking also affects memory and learning. Focused attention is essential for encoding information into long-term memory. When attention is divided, the brain struggles to encode and retain information, resulting in poorer learning outcomes. Students who study while checking their phones, for instance, retain less information and take longer to complete learning tasks. Similarly, employees handling multiple tasks simultaneously may make more mistakes and take longer to solve problems. These findings emphasize the importance of managing cognitive load and prioritizing focused attention for effective performance and learning. Not all multitasking is equally harmful. The impact depends on task complexity, similarity, and the individual's cognitive flexibility. Simple or automatic tasks, like walking while talking, can often be performed simultaneously without major decline in performance. Complex or novel tasks, such as studying or problem-solving, suffer more when attention is divided. Task similarity also matters. Performing two tasks that require the same type of processing, like reading two texts simultaneously, is more cognitively demanding than combining tasks that engage different modalities, such as listening to music while cleaning. Strategies to manage cognitive load and reduce multitasking costs include prioritization, focus management, and time structuring. Breaking tasks into smaller steps, eliminating distractions, and dedicating attention to one task at a time improve efficiency and learning. Techniques like the Pomodoro method, which involves intervals of focused work followed by short breaks, help maintain attention while reducing mental fatigue. Mindfulness practices enhance awareness of attention allocation, reducing unnecessary task switching and promoting cognitive efficiency. Cognitive flexibility, the ability to adapt thinking and attention, also influences multitasking ability. Individuals with higher cognitive flexibility switch between tasks more efficiently and manage interference better, though excessive multitasking still increases cognitive load and mental fatigue. In conclusion, multitasking and cognitive load are closely linked aspects of human cognition. While multitasking is common in modern life, it often reduces efficiency, accuracy, and learning due to the limits of attention and working memory. Cognitive load theory explains how mental effort is allocated and how overload occurs when tasks exceed the brain's capacity. Managing cognitive load through focused attention, task prioritization, structured learning, and mindful awareness enhances performance, reduces errors, and supports well-being. By understanding the cognitive costs of multitasking and implementing effective strategies, individuals can improve learning, productivity, and mental functioning in a complex, information-rich world. If you found this explanation helpful and informative, please like this video and subscribe to the channel for more educational content.